Welcome to our live training session. In this week's session, we're going to be looking at creating a Flappy Bird style game. So this is kind of a variation on the side-scrolling endless runner idea. So we have a list of goals for the session. So we're going to learn to create performant, infinite or endless style games by moving the world instead of the player. So this is a concept that some of you guys may be familiar with. It's sort of like, this is sort of an old reference, but the old Hanna-Barbera Flintstones style cartoons where you would see the background moving and looping past the character who's sort of standing in one place with their feet moving. So we're going to be doing that. In this case, our bird is not going to move, but the background is going to move behind them. And we're going to recycle and loop two sections of the background. And I'm going to show you guys that in a moment. We're also going to learn how to optimize your game using object pooling. So we're going to have columns that we're going to be flying past in this game. And instead of spawning hundreds of columns to create an endless level for the player to fly through, we're just going to have 5 columns that we're going to recycle once they've passed out of view of the camera. And that's also going to help us in terms of performance. And then the third sort of takeaway is that we are going to be creating cartoon style, non-realistic 2D physics using Unity's built-in 2D physics system. So we're not going to be using sort of accurate physics. We're going to sort of control the physics system ourselves to get a very precise and reliable style of jumping or flapping for our bird, using some scripting techniques to kind of modify and control the way that the physics work. So we have a link for the assets for this session, which you can download. If you're here live, I have pasted that into the chat. And if you are watching this on YouTube, you can just head to that link and grab the assets. The assets are really simple. It's just a few pieces of artwork and a font. And we are going to be creating this project basically from scratch using those few assets provided. This is going to be a little bit of a longer session than we usually do, but I think because this is more beginner focused, and I would like to show you guys the process, really just starting from a set of sprites and building everything up. I think there's going to be some value to that. So the first thing that I'm going to do is I am going to show you guys the finished version of the game, and then we're going to make a new empty 2D project in Unity and bring in our artwork. So I'm using Unity 5.5, but nothing that we're doing here is super specific to that, although that is the version of Unity that we recommend for this. Okay, so here you should see on your monitor the completed version of the project, which I'm just going to enter play mode and demonstrate quickly. So you can see I've got the scene view visible here. You can see over to the left those columns that have spawned off screen. And as I get closer, we can see new columns being spawned. And as you can see just happened there, as I get a certain distance over to the right, our background moves from its position on the left over to the right and jumps in front of the player to allow the player to keep going. And then if I crash into something, we switch to our little dead bird sprite and we can tap the button to restart and it will reset the game and we can continue playing. So we're going to use this to kind of illustrate these best practice concept for endless worlds of recycling these chunks of the level and object pooling our different columns. And this is also going to be done in such a way that if you are a real beginner, it should be relatively easy to follow. And for those of you guys who are a little bit more intermediate, hopefully you'll get something out of the kind of best practices that we're demonstrating here. So I'm going to go ahead and open another instance of Unity. This is 5.50 F3. I'm going to create a new 2D project. This is going to be called Flappy Bird Live. Hit Create Project. And we can close the earlier open version. And so now we have a new blank 2D project. And so the next step is going to be to import and lay out some artwork. Before I do that, let me just take a quick look at the chat and make sure that everybody's doing okay. And then we are going to dig in. So I have the assets here, which if you unzip the zip file, you will find a folder which contains two subfolders for fonts and sprites. And what I'm going to do, so I'm just going to drag those two folders into my, I'll just show the window so you can see me doing it. I'll drag the fonts and the sprites folders into the project folder. That's going to import those. And we're going to start by working with the sprites. Now, the first thing that we're going to want to bring in is our bird hero. Now, if you've set this up correctly in having your project in 2D mode, these should be brought in automatically as sprites, as single sprites. But in this case, there's an additional factor for the bird hero, which is that there are actually 3 sprites in this one file. So what we're going to do is we're going to switch our sprite mode to multiple and apply that. And then we're going to open the sprite editor. The sprite editor is going to allow us to cut out each of these sprites individually, and we're going to do that using the slice tool here. So the type being automatic is fine. It'll guess accurately where the sprites are, so all we need to do is hit slice. And we can see these bounding boxes show us where the sprites have been cut out, and that looks great. So we're just going to go ahead and apply those changes and close the sprite editor. Now, if we expand our bird hero, we'll see that we now have 3 separate sprites which we can use. And we're going to use these to animate our bird, which we will do a little later in the session. We're going to start by just dragging in our bird hero 0 sprite directly into the hierarchy. Dragging it into the hierarchy will position it at 0, 0, 0 at the center of our world or origin. And so we're going to start by getting our bird in. We're going to name him Bird. And then we're going to bring in our grass and our sky. So I'm going to grab next the grass thin sprite, drag it up, and drop it in the hierarchy. And this needs to be positioned a little bit. So we're going to just drag it down until the bottom is more or less aligned with the bottom of the game view. I recommend working in this kind of a 2x2 layout so that you can see both the scene and the game view. And I did that just by dragging on the Y field in the transform. So something like -2.5 should be good for that. Next, we're going to bring in our sky background, and this I'm going to drag on top of the grass thin sprite. And that is going to cause it to become a child of it so that we can move them together once we start moving the elements of our level. I'm going to rename the grass thin sprite ground. Now, as you can see, things have gone a little bit wrong. Our sky is now in front of our ground and our bird, and that's not the way we want it. So we are going to set this up using what are called sorting layers to position which sprites are in front of the others relative to the camera. So the first thing that we're going to do is position the sky tile sprite. So make sure that that's selected. And then we're going to go to the sorting layer menu, which is in the sprite renderer component attached to that game object. And we're going to click on it and choose add sorting layer. Now there's always going to be a default sorting layer, which is always the bottommost or furthest from the camera. And then as we add new layers, those will be in front of that default layer. So what I'm going to do is add a layer called background, which is going to be the layer that the sky is going to be on. Then we're going to have a midground layer and a foreground. Now we need to assign our sprites to these layers. So the sky tile sprite is going to be assigned to the background, and we can rename this just to sky background. And the ground is going to be on the foreground layer so that it will be in front of the sky. Next, we're going to take our bird and assign them to the foreground layer as well. So now we've got things sort of positioned relative to the camera correctly. And the next step is going to be to add some physics components to our scene. So we have what we want is we want the bird to be able to fall down and hit the ground. So right now, nothing has a rigid body or a collider on it, which are the components that we need to set up our 2D physics. So we are going to go ahead and start by adding a rigid body 2D component to our bird so that it can be affected by the 2D physics simulation. So we're going to choose Add Component, navigate to Physics 2D, and choose Rigid Body 2D. The default settings for the bird are fine. If we hit play, we'll see that our bird falls off the scene, but they fall right through the ground, which is not what we want. So we need to add colliders to both the bird and the ground so that we can detect collisions between them. Let's start by adding one to the bird since he's already selected. With the bird selected, we're going to choose Add Component. Again, Physics 2D, and we're going to add a Polygon Collider 2D. What this will do, if we zoom in on our bird using the mouse wheel, we'll see, it's a little bit difficult to see, but this green line has been added around the bird's sprite. And what it's done is it's sort of traced the outline of the sprite and added a collider that follows that outline. And in this case, it's done it in basically an appropriate way. And so we can leave it as it is. It's possible to edit it as well, but in this case, that's not necessary. The next thing that we need is a collider for our ground. We're going to select the ground game object, choose Add Component, Physics 2D, and choose a Box Collider 2D. Now in this case, we can see this green box has been added. Again, it's a little bit difficult to see against the blue, but it's not positioned in an appropriate place. It's much too high. So the first thing that we're going to do is adjust the size along the y-axis here in the Box Collider 2D component. We're going to drag down till it's about 2.5, and then we're going to pull it down using the offset y property to about, let's say, negative 1.4. So in this case, now the ground is aligning with the line of the ground. I've placed it below the grass. And now we should be able to play and test. And we can see that our bird falls down onto our grass and things appear to be working correctly. So now that we have some kind of very basic physics set up, the next step is going to be to write a script which is going to control the bird and allow him to jump up and down so that he can navigate through our scrolling world. Let me just take a quick look at the chat before we move on to that next topic. All right, so let's continue. So the next step is that we're going to write our first script, which is going to be the script which will control the bird. So I am going to select the bird game object, go down to click Add Component, and I'm going to type the name bird. This is a quick way to both create and add a new script. So because there's nothing named bird in our assets or in the Unity component reference, we're going to create a new script and then click Create and Add. And this is a new C# script. That's now created a new script in the root level of our project. We can collapse the sprites folder for now. and it is attached to the bird game object. We're next going to, I'm right-clicking to create a new folder, which is going to be called scripts, and I'm going to drag my bird script in there. Okay, let's expand that and double-click on the bird script to open it for editing in our script editor, MonoDevelop. All right, so now the first thing that we want to do is to check if the player has tried to click to move the bird. Now, the rules of the game are going to be that if the player is dead, they cannot jump up off the ground and start flying again. So the first thing that we want to make sure is that if the player is dead, we're going to stop them from flapping. So we are going to add at the top of our script a private Boolean variable called isDead. We're going to use isDead in update to check if the player is dead or not. And isDead by default will be initialized to false. So when the game starts, the player is not dead, they're alive. Now, in the update function, we're going to check if isDead is equal to false. So if the player is dead, this code within these brackets will be ignored. If they're still alive, we are going to be allowed to check the next conditional, which is if input.getMouseButtonDown 0, which is for the left mouse button. So if the player has left clicked, then we're going to do the code in this next nested set of brackets. Now, the code that we want to do is that we want to add some force to the rigid body 2D component that we attached to the player earlier. So in order to do that, we need a rigid body variable. So we're going to add another private rigid body 2D, and we're going to call it RB2D. Now, in order to use this variable, we need to have our script get a reference to it. So what we're going to do is in start, we're going to say RB2D equals get component rigid body 2D. What this is going to do is when the game starts or when this object becomes enabled, it's going to check on the game object that this script is attached to if there's a component of the type rigid body 2D attached. If there is, it will store it in the RB2D variable so that we can do physics stuff with it as we continue. So now we have our rigid body 2D variable, and so if the player is not dead and if they've clicked the mouse button, the first thing that we're going to do is we're going to set RB2D dot velocity, the velocity of that rigid body, to equal vector2.0. So what this means is our rigid body 2D is always going to be either rising because the player has flapped or falling because the player hasn't flapped and they're being affected by gravity. Now, the result of that will be that every time we jump, we'll get slightly different behavior because we'll have to either equal out the downward motion that's already there or we'll be adding to the upward motion that's already happening. And that's going to give us a sort of inconsistent behavior. So for games where you're going for a sort of more accurate simulation feeling, like let's say maybe a pool or billiards game or some other game where sort of physics were integral to the gameplay, you wouldn't want to do this type of thing. But for this, we're looking for like a sort of cartoony, almost Super Mario Brothers type of physics where every time we push the jump button, we're going to get the exact same response. And that's actually really important to the gameplay here. So what we're going to do is every time the player jumps, we're going to reset the velocity to 0 so that the next thing that we do will always be the same. And the next thing that we're going to do is we're going to add some force to the rigid body 2D by using RB2D.addForce, and we are going to need a amount of force to add. So we're going to add a public variable, which is going to be of the type float, and that's going to be called up force. And we're going to initialize that to 200. Now, we're going to use up force to create a new vector2 to pass to RB2D. So a vector2 is going to store two floating point values which correspond to the x and the y axes. So in this case, for the x-axis, the horizontal axis, we're going to set it to 0. We don't want to change the player's horizontal movement because remember, the player is not actually moving horizontally. The world is going to be the thing moving horizontally. The player is just jumping up and down in place as the obstacles move around him. So we're going to set the x for, we're going to add 0 units of force along the x-axis, and we're going to add up force along the y-axis. So now we can save this script. Just hit OK to this warning about the line endings. This is just a file formatting issue. It doesn't affect the gameplay. Just going to hit OK. And we can return to Unity to test our flapping behavior. So if we play the scene and click, we can see that we can now jump up and down in place. We can jump as many times as we want, or we can flap as many times as we want, and we can fall to the ground. But in this case, we have nothing to tell us to stop flapping because we have nothing setting is dead to true when we hit the ground. So that's the next thing that we're going to add. So I'm going to exit play mode and switch back to monodevelop. And so we need to check if the player has hit the ground or any other obstacle for that matter, like the columns that we're going to have. So we're going to do that using a function called onCollisionEnter2D. So we're going to type void onCollisionEnter2D. Make sure that the capitalization is exactly the same as I've typed it. This is a function from Unity's API, so Unity will always be listening for this function. And if a game object that has this script attached to it registers a collision with something else, it will call this function and do the code inside it. So what we're going to do is we're going to say isDead equals true. So now, once isDead becomes true, in update, we'll no longer be able to flap because this check will fail or evaluate to false. So let's save our script again, return back to Unity, and test. So now I'm just going to allow the bird to fall to the ground. And now no matter how much I click to try to flap, I cannot get off the ground because I am dead. So that's almost everything that we need for our bird. The only other thing that we're going to need are some functions or some lines of code which are going to allow us to play the animations. So switch to our wing flapping and our dead animation states, along with an animation controller to control the transitions between those states. And we're going to move to that in the next topic. First, I'm going to take a look at the chat and see how everybody's doing. Somebody's asking if I change the rigid body settings, the chat is correct in saying, no, I didn't. I'm using the default settings. And yes, somebody else talking about the bird. The bird is not actually going to move. The bird is just going to move up and down, and the world is going to scroll to the right or to the left while the bird stays in place. So it looks like the bird is moving, even though they're not. Somebody asks, could you also write rb2d.velocity equals new vector200? You sure could, but there's no real reason to. Yes, vector2.0 is just a shortcut for 0, 0. Okay, great. Somebody's asking, why not use a coroutine? The main reason for not using a coroutine is that it requires more management. The coroutine needs to be started and stopped, which requires extra lines of code that you may not need. And also, as somebody else says, the coroutines are prone to allocating memory, which can lead to garbage collection and therefore loss of performance at runtime. So generally speaking, unless you really need a coroutine or unless it's just something to run once, like fading in the scene or doing something like that, I recommend avoiding them during your repetitive gameplay code. The next step is going to be setting up very simple animations for our bird to switch between our 3 sprites. So we're going to do this using the animation window, the animator window, and a few lines of code. So first of all, we need to select the bird game object and go to Window, Animation. You can also push Control 6. This will open the animation window. This is kind of huge. I'm going to take it and dock it with my scene view. And there's a little shortcut here to begin animating our bird, create an animator and an animation clip. We can just hit the Create button, and we're going to use that. So click Create with the bird selected. And our first animation is going to be called Idle. That's sort of the default frame that the bird is in now. We're going to name this file idle, and then we're going to make a new folder called animation and save that file in there. Now you'll notice when we do that, it adds an animator controller here. It adds an animator component and creates an animator controller asset. And we're going to look at that animator controller in a second. So by doing that one thing, we've created 2 files and also added an animator component to our bird. So a couple sort of automated steps there that Unity is doing for you to get you ready to animate. Now, the animation on this is going to be really, really simple. It's just going to be changing what sprite is being displayed in the sprite renderer when we tell it to. So all we need to do is, with the bird selected, click Add Property, unfold the sprite renderer, highlight the sprite property at the bottom of that category, and then just scroll over a little bit so that you can see the plus button, which is sort of hidden by the edge of the window, and hit the plus button here. So scroll over and hit plus. Now, since there's going to be no beginning and end to this sprite, we can actually just highlight the keyframe, which is the little diamond icon here, and delete the second keyframe. And so now we just have an animation which is 1 second of the same sprite, which is our default idle sprite. Now, what I'm going to do is I'm going to drag to select that and then choose Edit, Copy. You can also push Control C. Now, I'm going to create another animation clip, which is going to be our second image. So we're going to click on Idle, click on the drop-down menu here, and choose Create New Clip. And this one is going to be called Flap. Hit Save to create the new animation clip. And now all we need to do is just click somewhere in the animation window and choose Edit, Paste to paste back in our single keyframe sprite change or setting of the sprite that we did in the other clip, but now we're going to change it. So we can see over here in the inspector that the sprite is red, and that's because any changes we make to it are now going to be recorded into the animation. And so what we're going to do, and that's because this record button is highlighted here, and that's done by default when we create the new animation. What we're going to do is we're going to unfold the sprites folder, and we're going to grab Bird Hero 1 and drag it into the sprite field. Now we can see that the game view updates to show the bird is flapping his wing, right? And now our flap animation clip is ready to go. Now we're just going to create our third clip, which is going to be our die clip. So we're just going to choose Create New Clip. Call this one Die. hit save. Again, click in the animation window. I'm going to use the keyboard shortcut Control V to paste it in and select the bird. And I'm just going to drag in my Bird Hero 2 sprite now, which is the dead bird. Now, each of these clips is ready to use, but we need to set up the rules from which we will change from one clip to another, or under which we will change from one clip to another. So when we started setting up our animation, it opened the animator window, right? As distinct from the animation window. So we're going to switch to the animator window. And we'll see here that we have three states that have been created for the 3 clips that we created. Now, I'm just going to arrange them a little bit just by left clicking and dragging. Put them relatively close together so we can see them all. So the entry node here is when the animator becomes active and starts evaluating the state machine here. This is where we're going to start. So we're going to start at entry, and each of these lines represents a transition. So the default transition, and the reason that this is sort of golden orange, is that we are going to start and go straight to the idle animation clip or state. The state which references the clip, which is here. So what we're going to do is we're going to set up conditions under which we're going to go from idle to die and from idle to flap. Now, to do this and to control this via script, we're going to need 2 of what are called parameters. And so over here on the left, you'll see a list of layers and a list of parameters. In the list of parameters, we're going to hit the plus button and create a trigger parameter. This trigger parameter is going to be called flap with a capital F. And so we're going to set this trigger via script every time we want our bird to transition to the flap state and play the flap clip. We're also going to have a second trigger parameter, and I'm clicking on the plus button here to bring up this menu, called die with a capital D. The names are important because we're going to be referencing them via string, via script, so make sure that they match exactly. Now, we've got our parameters ready to use. We need to create some transitions between these different states. Let's set up the transition from idle to die first. To create a transition between 2 states, I'm going to right-click on idle, choose Make Transition, and drag to the die state. Now, to edit the conditions under which this transition will happen, I'm going to click on the transition itself on this little arrow on this line. Now, right now, there's one condition which has exit time. What that means is once we've gotten to the end of the 1 second for idle, it will transition automatically. We don't actually want that to happen because we want idle to loop and remain active until the player dies. So we're going to turn off has exit time, and we're going to add our own condition to the list of conditions here. We're going to hit the plus button in the list of conditions, and flap is the first in the list, so that's going to come up, but we're actually going to select die. So when the die trigger is set via script, then we're going to transition to the die animation. And you'll see once we turned off exit time, we got a little warning here because without exit time and any condition here, there's no way that that animation transition will ever happen. But we've solved that now, so we can actually clear that error from the console, or that warning. Okay, now we're never going to transition from die back to idle because when the game ends, we're just going to restart the whole level and reset everything. So that's okay, having a single transition going in that direction. The next thing that we're going to do is we're going to transition from idle to flap and back. So let's click on idle, right click and choose Make Transition, drag to flap and left click. And this, we're going to turn off has exit time as well. And for this one, the condition is going to be the trigger flap. Now, all we need is a transition from flap back to idle. And for this, we will use has exit time. So basically, we're going to transition from idle to flap when the trigger is set, And then Flap will wait for 1 second, the default length of the animation clip, and transition back to idle once it's finished playing. So now we can play our scene. Let me make sure that the record button is turned off in the animation so I don't actually accidentally animate something I don't mean to. I noticed that because my play button was red. So just make sure that's off so you don't accidentally add animation unintentionally. And so now we can play our scene and experiment with these triggers. So I'm going to play. The bird's going to fall to the ground. And now when we can see that we're currently in the idle state, right? When I manually click the die, we can see that it transitions to the die state and my bird dies. Now, there's no way to go back, so let's exit play mode and re-enter play mode. And for Flap, we can test by clicking Flap. We can see the wing goes up, and then it comes back down. So that is all working as intended. The only thing that we need to do now is write lines of code in our script which will set those triggers at the appropriate moment. So let's double click on our bird script again to open it for editing. Return to MonoDevelop. And now what we're going to need to do, just like we added a reference to the rigid body 2D component, we're going to add a private animator variable, which we're going to call anim for short. And we're going to get and store a reference to it in start as well. So we're going to say anim equals get component animator. Now we can send commands to the animator component using the anim variable. So what we're going to do is when we're adding force in update, we're also going to play our animation. So we're going to use anim.setTrigger and pass in the trigger that we want to set. And we're going to pass it in using its name as a string. To pass it as a string, we need to set it in quotation marks and type it exactly as we set it up in the animator. So we're going to call anim.setTrigger and pass in the string parameter flap. To transition to the die state, we're going to call anim.setTrigger, and in this case, we're going to pass in the string die. And that is going to be called from within onCollisionEnter2D so that when the bird crashes into something, we're going to set isDead to equal true so he can't flap anymore, and use anim.setTriggerDie to transition to the dead sprite. Let's hit Control S to save the script and switch back over to the Unity editor. Now we can play our scene and test our animations. So we can flap by clicking, and we can die by falling on the ground. So we're off to a good start. Let me pause for a moment and check the chat for questions. In the next phase, we're going to move on to setting up some UI to show the score and a game over message, as well as write a game controller script. Nitroba asks if these animations would apply the same if you were using 3D assets. Yes, the same principle would be true. The animator would be set up in the same way. Let us continue. All right. So the next step is that we are going to add some UI so we can display the score and also our game over message. So we can close the animator tab and the animation tab. And I'm just going to zoom out the scene view a little bit using the mouse wheel. And now is probably a good time to save our work, since apparently there are gremlins in the matrix. So I'm just going to go ahead and choose File, Save Scene, and I'm going to call this scene Main and save it. And let's make a folder called scenes and stick main in there. All right, great. So the next step is we're going to create some UI text for our score. So in the hierarchy, I'm just going to right click, scroll down to UI, and choose text. Now this is going to do a few things for us at once. First thing it's going to do is create a canvas, which the UI is going to be a child of. Any UI objects we make need to be children of a canvas in order to be rendered. It's also created an event system, which we need if we're going to interact with our UI, like buttons or sliders. In this case, we're not going to interact with our UI, so we can actually select the event system and delete it. And now we are going to set our text. Now I'm just going to, with the text selected, place my mouse over the scene view and press F to frame selected. And so that we can see in context of our UI frame. Now the first thing that I'm going to do is set my score type score :0 in the text box. And I'm going to set the font from the default Arial to our luckiest guy font that we imported. Let's scroll in a little bit. We can see the changes being made. We're also going to set the font to about 32. Now notice it disappears from the text box when we do that. That's because it's gotten too big for the text box. Because we're not going to do a lot of precise text stuff, we can just go ahead and set the horizontal and vertical overflow to overflow out of the box if it gets close to the edges. And we're also going to set the color of the text to white. The next thing that we want to do is we're going to choose center and middle alignment within our box, but we also want to align our text object within our overall frame. So we're going to use the anchor presets to do this. I'm going to click on the anchor presets, and in order to set the position here, it says Alt, also set position. I'm going to hold down the Alt key and click the bottom middle or bottom center preset here. And that is going to position it nicely at the bottom of the screen near the middle. And then I'm just going to give it maybe 50 pixels along the y-axis up from the bottom of the screen to position it right about there. And I'm also going to add a shadow effect to the text using the shadow component. So I'm just going to choose add component, and we're just going to do this by typing the name of the component. So we're just going to type shadow, or shad gets us shadow, and we can set the effect distance to maybe 1.5 or 1.8 on the X and something similar on the Y. So it's fairly subtle here, but it's just adding a little dark drop shadow to our text so that it can be read against whatever background. And so let's label this game object. Let's name this game object. We're going to call it score text. And we're going to need another text object as well, or actually another two, to display the game over message. So I'm actually just going to duplicate this score text game object. We're going to go to Edit, Duplicate. You can also use Control D. And I'm going to call this one Game Over Text. And I'm going to change the text to read Game Space Over. And this one, I'm going to anchor at the top center. So again, using the anchor presets, holding down Alt, click, we can see it's a little squished up against the edge. We're going to set this to around -50 on the y-axis. Now this one is going to be a little bigger. Let's set this to maybe 48. And we're going to duplicate the score text one more time and make that a child of the game over text. We're going to reset the Y position to just position it right up under it. And this one is going to read flap to restart. And we'll maybe make this a little bit smaller. Let's make this 24-point font. Now, the game over text is not going to be visible at the beginning of the round, so we're going to select the game over object and disable it using the checkbox here in the inspector. So now, when it's time for the game to be over, we just enable that and it'll display our message for us. Okay, let's save our scene. File save scene or Control S. And let me look at the chat. Okay, somebody is asking, is this game for Android or PC? Either in this case. Nothing we have done so far is specific to one platform or the other. And because it's a simple and relatively optimized 2D game, it should run fine on mobile. I'm not going to show building to a mobile device in this session, but you can carry on with this. There are actually some really good building to device tutorials that my colleague Kerry from the R&D content team at Unity just wrote recently that are up on the website. I can dig those out and link to them a little later on. And if you want to build to mobile, you can take a look at those. All right, so we've got our basic UI set up, and what we're going to move on to is writing a script which is going to decide, among other things, when to display that game over message. So this is going to be our game control script. So this is going to manage the score, show the game over message, restart the level, and generally keep track of the state of the game. So whether the game is over, whether the game is running, and so on. So we're going to create a new empty game object. Let's go to game object, create empty. We're going to call this game controller. And we're going to add a new script, which is also going to be called game control. And we're going to hit new script and then create and add. And we're going to double click this script to open it in Unity, to open it in MonoDevelop. And so the first situation that we're going to take care of is when the bird dies. So we're going to have a function for that. We're going to have a public function that returns void, which is going to be called bird died. And what we want to do here is we want to enable the game over message, the text that we just set up. So we need a variable to be able to access that. So we're going to create a public game object variable called game over text. And in bird died, we're going to call game over text dot set active and pass in true. So that is going to enable our disabled game object. The other thing that we're going to want to do is update the state of the game. So now that the game is over, we want to keep track of that. So we're also going to add another public variable. This one is going to be a bool called game over. And by default, when the game starts, game over will equal false. Now, in bird died, we want to set game over to equal true because the game has now ended. So this game control object is going to keep track of the state of the game, and it's going to make that state of the game available to other scripts like our bird script that we just wrote. And so we are going to make this, we're going to use what's called a singleton pattern in order to allow this game control to control the game and to make sure that there's only ever one game control that's active. We really do not want multiple objects trying to say that the game over or no, it's not over, or updating the score independently. So we're going to use what's called a singleton pattern. And just to give you a kind of a quick definition of that pattern from Wikipedia in this case. So in software engineering, the singleton pattern is a software design pattern that restricts the instantiation of a class to one object. This is useful when exactly one object is needed to coordinate actions across the system. The concept is sometimes generalized to systems that operate more efficiently when only one object exists, or that restrict the instantiation to a certain number of objects. The term comes from the mathematical concept of a singleton. So there's a really simple little block of code that we're going to use to enforce this singleton pattern. So the first thing that we need to do is to create a static variable, a public static game control, and we're going to call this instance. Now, by making this static, we associate this with the class, and we allow it to be accessible very easily from any of our other scripts, as we'll see in a moment. So once we've declared that variable, we're going to take start and change it to awake. Now, awake is called before start, and generally, if we had any other processes that might begin in the start function, we want to make sure that the game control is set up before them. So we're going to do it in awake. Now, what we're going to do is we're going to enforce our singleton pattern by making sure that there are no other instances of game control already existing when this one comes online. So first of all, we're going to say if instance equals null, meaning there's no game control found. Then instance equals this, right? So we came online, we discovered no other game control, everything is fine, this is the game control. However, else if instance does not equal this, meaning instance exists and it's not this one, then we're going to use destroy game object, meaning destroy the game object that this script is attached to. So if an instance of our game control starts up, it's going to look around, say, is there another game control around? No? Okay, I'm in charge. If there is, however, it's going to say, okay, I'm not needed, and destroy itself. So what setting this static variable up allows us to do is in our bird script, we can now really easily call our public bird died function of the game control. So let's return to the bird script, and in on collision enter 2D, we're going to type game control dot instance dot bird died. And that is how easy it becomes to access a variable or to call a function of the game control from another class. Now we can just type game control dot instance dot whatever it is we want to access. In this case, bird died. So let's save our bird, save our game control, and now if we return to the Unity editor, so now before we play the scene, we need to assign our game over text. So I'm going to grab the game over text that's deactivated, drag it into the game over text variable, and play the scene. And we drop to the ground, the bird dies, and the game over text is displayed. Now, what we want is we want to be able to click the mouse or tap the screen and reload our scene. And so that is what we're going to take care of next. So back in our game control script, we are going to, in update, check to see if the game is over. And once the game is over, if somebody has flapped, right? If they've tried to click or tap the screen of the mobile device. So we are going to set if game over. So we're going to add an if statement, and we're going to check if game over equals true, and the double ampersand means and input dot get mouse button down 0. So left click. So both of these conditions have to be true for the code within these braces to be executed. So the game needs to be over and the player needs to have attempted to flap using the mouse or a tap. Now what we're going to do is reload the scene. In order to do this, we need to add the namespace declaration using Unity Engine.scene management. So this allows us to access the scene manager, which is what we're going to do. So we're going to type scene manager dot load scene, right? So this is going to allow us to load a scene file. And in this case, what we're going to load is scene manager dot get active scene dot build index. So basically, we're going to tell the scene manager, please reload whatever scene is currently active, which in this case happens to be our main scene. So hit OK on that dialog box, save. Let's jump back over to Unity. And now, when we test, fall to the ground, the game is over, we click, and it reloads the scene. So now we have the capability for our game to end, our game to restart, and the only other thing that we need to add in game control is scoring, which we will do once we've added our obstacles. The next thing that we are going to do is we're going to add our horizontal movement by scrolling our background. And I'm going to exit play mode, and we will do that in the next topic. Before we move to that, I'm going to check the chat for some questions. We're going to move on now to setting up our background scrolling. So the first thing that we're going to need to do is to create a new scrolling object script, which we're going to add to the ground. So let's select the ground, and we're going to choose Add Component and type Scrolling Object, and select New Script, Create and Add. And while we're at it, let's clean up our project a little bit. We'll put the game control in the scripts folder and the scrolling object in, whoops, not the sprites folder, the scrolling object as well. And then we'll double click scrolling object to open it for editing. And so scrolling object is going to be a really simple little script. It's going to, actually, before I start with scrolling object, it's going to need a rigid body 2D. So let's just add that before I forget. Let's jump back to Unity, and we're going to select the ground game object and choose Add Component, Physics 2D, Rigid Body 2D. Now, this rigid body is, we're adding this because we want to move the object, but we don't want it to actually bounce around or be affected by gravity. It's just going to be there so that we can scroll the ground to the left. So we're going to set the body type to kinematic. And what that means is it won't be affected by gravity. It will only be moved by script. So we've added a rigid body 2D to the ground, and we've set its body type to kinematic. Okay, let's continue in our scrolling object script. So the first thing that we're going to add is a private rigid body 2D variable, again called RB2D. In start, we're going to get and store a reference to it. So we're going to type RB2D equals get component rigid body 2D. And that is going to check for a rigid body 2D attached to the game object that the script is attached to and store a reference in the variable. We're also going to set the velocity of the rigid body 2D. So we're going to say rb2d dot velocity equals a new vector 2. Now, we need a speed value to set this to, and because we're actually going to be moving multiple objects, so we're going to be moving 2 different pieces of the ground in order to achieve our looping background effect, and we're going to be moving all of the columns, and we want them all to move at the same speed. So let's open our scripts here. This is another way that you can access your scripts from the solution menu in MonoDevelop. And I'm going to reopen game control. We're going to add a public variable to game control, which is going to be a float, and it's going to be called scroll speed, and it's going to be equal to -1.5. And don't forget to add the lowercase f because it's a float. Now, adding this here, it's public and it's going to be accessible via our static instance variable, right? So this makes it very easy to make this scroll speed accessible to all of our different scrolling objects from a centralized location. So let's go back to scrolling object, and now in our vector 2, the x value is going to be gameControl.instance.scroll speed. So we're just plugging that value directly into the vector 2 there from the game control, and then the velocity along the y will be 0 because we're not going to want this to move up and down as it scrolls. Now, the only other thing that we need to concern ourselves with is making sure this stops scrolling when the game is over. And we're going to do that in update. So in update, again, we're going to check the game control. So we're going to say if game control dot instance dot game over equals true. And I'm just spelling out that equals true to make it really explicit. And then rb2d.velocity equals vector2.0. So we're going to stop any and all objects that have the scrolling object component attached to them when the game control says that the game is over. Let's save that. Jump back over to Unity, and I'm getting an error in the console here that says the game control doesn't contain scroll speed. That means I haven't saved my changes to game control. Let's go back to MonoDevelop, back to game control, and use Control S to save. And then we'll go back to Unity and wait for it to compile. That error now clears, so that was the problem. And we're going to play our scene. And now we can see our background moves, but we are flying off into the cold blue vacuum of space. And that's not really what we want. So we need to set up our repeating background effect. And so the first thing that we need to do is to make another copy of the ground so that we can have one that's visible and the other that's being repositioned. So let's make sure the ground is highlighted, right click, choose duplicate, or press Control D. I'm going to call this ground 2. And while we're at it, let's just make I'm right clicking and choosing create empty to make a scenery holder object. This is going to have no gameplay purpose. It's just going to keep the hierarchy here from getting cluttered. So collapse the canvas, clean things up. And now we have the scenery with ground and ground 2. let's take ground 2. And what we want to do is, let's actually push F to frame selected so we can get a view. Right now, these are both right on top of each other. We want ground 2 to be exactly the length of the game object in front of the other. One way we can do this, if we look at our collider, we can see that it matches the length exactly. So let's go into the collider component and get the X size. In this case, it's 20.48. I'm going to use Control-C to copy that. And then I'm going to set the position. Oh, wait a minute. I made a mistake here. The scenery got made way off in the middle of nowhere. Let's unparent these. This is an easy mistake to make when you make new empty game objects. Just make sure that they are positioned at 0 so that we don't get crazy offsets. That was like off in the middle of nowhere. Let's reparent. And now it should be okay. So now what we're going to do is we are going to take ground 2. We've copied the size, and we're going to set ground 2's X position to 20.48. And as we can see, if we zoom in, that's made a nice seamless background. Let's just double check it to make sure there's no seam. Yeah. So that's working. But again, right, you can see as we get to the edge, we're still running out. So what we need now is we need to make a script that once we get past this first one, and this one is the only one that's visible, or this first chunk of the level is out of view, once we get past that, we'll jump it over, right, leapfrog it in front of the other one, and position it so that it's ready to scroll once the player gets through this one, right? So we're going to write another script to do that, which is going to be called repeating background. So let's select both of these game objects. I'm doing this by clicking one and holding down Shift and clicking on the other. I'm going to choose Add Component and type the name of a new script, which is going to be repeating background. Hit New Script and create an add. And then we're going to double click that to open it in MonoDevelop for editing. So this is also going to be a pretty simple script. We are going to start by adding a private box collider 2D variable, which is going to hold a reference to the box collider attached to the ground. This is going to be called ground collider. And we're also going to add a private float called ground horizontal length. And this is where we're going to store the length along the x-axis, that same value that we copied to position the second ground object. And so we're going to get that from our collider in start. So the first thing we're going to do is get a component reference to the collider. So we're going to say ground collider equals get component box collider 2D. And then ground horizontal length equals ground collider dot what is it called? Ground collider dot size dot x. So we're going to get the size of the collider along the x-axis and store that in our float ground horizontal length in start. Now, we're going to need a function which is going to reposition the background when it's time to move that. So let's write that first. So we're going to write a private function that returns void, and that's going to be called reposition background. And in it, we are going to create a new vector2 called ground offset. And this is going to be how far we're going to move our ground forward when it's time to reposition it. And this is going to be a new vector 2, which is ground horizontal length times 2 along the x and 0 along the y. So we're going to double the length of the collider and jump our object past the one that's visible into a new position in front so that it's ready to scroll into view. And then once we've calculated that offset, we're going to actually apply it. So we're going to say transform.position. The position of this object is going to be equal to a vector 2, and we need to cast transform.position to vector 2 so it doesn't get confused with the vector 3 transform.position. And then we're going to add ground offset to that position. So now this is going to calculate how far it has to move and then actually move it. And finally, in update, we just need to check, is it time to reposition? Has this object scrolled out of view? So we're going to check if transform.position.x is less than negative ground horizontal length. So we're going to calculate a negative number from 0, right? Remember, our camera is looking at 0. So if one of our objects is scrolled to its full length to the left, in this case, then it's going to be ready to reposition. And so we're going to check if the x position of this object is less than its length to the left, then we're going to call reposition background. Okay, so let's save that. All right, so we've got reposition background written. We've got our scrolling object written. And now it is time to test. Let's make sure these are both saved. Control S, Control S. And let's jump back over to the Unity editor. And so each of these ground objects should have a scrolling object, a kinematic rigid body 2D, and a repeating background component. And now, if we play, we can see the background is scrolling. And if you look, let me actually make this bigger. Whoop, zoom, click. If you see the white frame around the player, you can see that is the camera view frustum. So that is the viewable area of the camera. And watch, you'll see as the ground moves out of view, boink, it gets moved in front, right? So the player is never moving, but the ground is scrolling from right to left and then getting repositioned once it's off screen. And so we can just infinitely flap to the right forever and ever. Blat. But you can see there's a little bit of an issue there with the physics that when we hit the ground, the bird kind of slides to the left. So as part of our kind of cartoony physics, we don't want that to happen. So let's just quickly jump back over to MonoDevelop. And in our bird, we're going to just reset the bird's velocity in onCollision enter 2D. So we're just going to say rb2d.velocity equals vector2.0. Just the same as we did for the jump force. We're just going to zero out the velocity. So he's just going to fall blat on the floor. Let's... Oh, I think that just got confused because blap, splat, splat. There we go. Very good. Okay. So that is everything that we need for our scrolling background. The next step is going to be to create our column prefab. Before I do that, let me just take a look at the chat and see how you guys are doing, and then we will move forward. Somebody's asking, maybe Unity Tech can answer if the acceleration add power is done in one frame. Yes, it is. That's basically what we're doing. The reason, so in some cases, many cases where you have continuous physics forces being added over multiple frames, you want to do your physics in fixed update. In this case, because our bird is only getting a pulse of physics that are being added once in one frame during update, we don't need to do that, right? Anytime you're just doing one hit of physics that's not happening over multiple frames, it's okay to call it from update. Like if you're launching a projectile or doing a jump in this case, it's okay. If you have like a character motor that is adding physics over multiple frames, then you're going to want to make sure that you're adding those forces in fixed update. And somebody's asking, how do you stop the ground? The ground is stopped in scrolling object, where we're checking if gamecontrol.instance.gameover equals true, the velocity of the ground is set to 0, right? So we're every frame we're checking whether the game is over, and then we are setting the velocity to 0, so it'll stop. So anything with a scrolling object will stop once game over becomes true. Somebody asked, why can't we instantiate the ground as a game object instead of moving it? That's a good question. The reason we're only going to instantiate objects at the beginning of the game, which we're going to show in our next script, or the script after next, our column positioning script, is because every time you instantiate or destroy a game object, you allocate a little bit of memory, which eventually builds up and needs to be cleared by the garbage collector. If the garbage collection happens during your gameplay, you're going to see, not always, depending on how much garbage has to be collected, but you're going to see a slowdown in performance. So generally speaking, you want to avoid garbage collection during your actual game loop, and therefore you want to avoid using instantiate and destroy during the actual gameplay. If you want to instantiate everything at the beginning of the game, that's fine. You might trigger some garbage collection before the game starts just to make sure that's all clear, but you do not want to do lots of calls to instantiate and destroy during the actual gameplay. One highly recommended resource is that my colleague, Carrie Turner, who actually helped me a lot in preparing this training, she's written a series of articles about diagnosing performance problems and optimizing performance both on the memory, CPU, GPU sides, which are all at unity3d.com/learn. I think the topic is called performance optimization. So I highly recommend you take a look at that. Somebody's asking for the scroll speed value. That is set to -1.5, and that's a public float, which is in the game control. The ground is a kinematic rigid body. The body type for the ground is kinematic. The next thing that we're going to do back in the Unity editor is we are going to set up our columns, which are going to be our obstacles for our bird. So I'm going to start in the sprites folder by grabbing the column sprite, dragging it in. This is going to land it at origin, and I'm going to set its sorting layer to mid-ground, so it's behind the ground and in front of the background. And let's pull it down. We're going to position it at -4, and we're going to add, so I'm positioning it at -4 on the Y. I just did that by typing it in. We're going to add a component, which is going to be physics 2D, box collider 2D. And I'm going to set the size on the X to 1. And again, I'm just typing that in. And you can see that being updated here. Switch to the pan tool so we can get a good view of it. So it's not perfect, but it's generally okay. You can wiggle it around to get it to, I'm not going to worry about those little edges. Let's just get it kind of generally on the body of the column. Okay, so once we've got that in place, I'm going to right-click, duplicate, and rotate it. So I'm going to go to the z-axis rotation in the transform component, and I'm going to type 180. And then I'm going to set the y position to, let's try, let's try 8. And we may need to mess around with this a little bit, but I think that should be good for now. And then we are going to create a holder object for both of these. So I'm going to right click, create an empty object. I'm going to name this object columns. And I'm going to make sure it's at 0. And then I'm going to drag both of the column sprite objects onto it. So now we have this holder object for the top and bottom of the columns, and we're going to add a trigger collider to it, which is going to be right here, so we can check to see if the player has made it through and scored a point. So with the columns game object, the parent, selected, we're going to choose Add Component, Physics 2D, Box Collider 2D, and we're going to make that a trigger collider. Now it's positioned it right here. We are going to use the Y offset to move it up so it's between these two. Drag the X to put it right on the far side, and then the Y size to just make sure that it covers the gap there. And let's just move this over a little bit to about here so that we can test. These are actually going to be positioned by a script, but for now, for testing, we're just going to move it over there to +5 on the X. Okay. So this is going to need a couple additional components. It's going to need a rigid body 2D, right? Because it's going to be moving. So let's add that. We're going to choose Add Component, Physics 2D, Rigid Body 2D. And this is also going to be body type kinematic, right? It's only going to be moved via script. And so we are going to add a script to this, which is going to check to see if the player has collided with our trigger and scored a point. So let's add component, and this script is going to be called column. I'm going to choose new script, hit create and add, and double click it to open it in MonoDevelop. And now this script is going to need to tell the game control that a point has been scored. So before we write the content of this script, now that we've created it and added it, let's jump over to the game control for a moment. And we're going to add a new public function. Let's add it above bird died. And this is going to be public void bird scored. This is going to be called whenever the bird scores a point, and it's going to be called from our column script. So in order to score a point, we need to have some concept of a score. So let's add a private int score and initialize that to 0. And then in bird scored, we don't want to allow the player to score if the game is over. So first we're going to check if game over. What we're going to do is we're going to return, meaning we're going to exit the function without doing anything else. So we're going to say if the game is over, return, don't try to score a point. However, if that's not true, we're going to move on to the next line here where we say score plus plus. And that's the same as saying score equals score plus 1. It's just a short way of writing it. Now, the next thing that we want to do is display the score using our score text object that we made. So we need to add the UI namespace to be able to do that. So we're going to scroll over to the top of the script, and we're going to add using Unity Engine .ui. That allows us to declare a new public text variable called score text. We're going to drag that in the inspector when we return to the editor. But first, in bird scored, let's display the score. So with score text, we're going to say score text dot text, the text in the text field that we're going to display equals score plus score, our int, dot toString. Okay, so now when the player collides with the column, we're going to have it call this bird scored function, which is going to check if the game is over and do nothing, or add 1 to the score and display it in the score text. So let's return to our column now. And in column, we can actually get rid of start and update because we're not going to use them. All we're going to use is a private void on collision enter 2D. And we're going to give this the parameter of the type collider2D called other. We're going to use this so that we can check what has collided with us. So and this is not on collision enter 2D, this is on trigger enter 2D. And that's a crucial difference, which would not work if I did it the other way, because we already set the collider on our columns game object to have the isTrigger property be set to true. So we want to check if we've passed through a trigger, not collided with a solid object. Okay, so in here, we're going to check if other dot get component bird does not equal null, meaning whatever passes through the trigger, we're going to check to see if it's a bird, if it has a bird component attached to it. If it does have a bird component, then we're going to call game control dot instance dot bird scored. And that is all we need for this script. It's super simple. Let's save it, return to game control and hit Control S there to make sure it's saved, and return to the Unity editor. Now, since we've added a new public variable to game control, we need to drag that in, our score text. Let's expand the canvas, grab score text, drag and drop. And now we should be able to test. Let's play. And as we can see, our column is receding forever into the distance because it's not moving. And that is because we forgot to add to the column a scrolling object component. So let's click Add Component, type scrolling object. That would be the most frustrating game ever, huh? I'm moving, but the column is moving with me. Okay, now, there we go. Now it moves in sync with the background, and we can see we get through, and our score is now 1 instead of 0, and we restart, and our score goes back to the 0. So all is well so far. The last thing that we're going to want to do is make a prefab out of these columns, because we're going to want to be able to spawn these via script. We're going to need a prefab, and let's put our column and our repeating background into our scripts folder. And let's create a folder called prefabs in the project and drag our columns from the hierarchy to the prefabs folder. That's created a prefab asset for us, and we can delete the columns from the scene because we're going to be spawning those in via script, which we are going to do in our next section, which will be our last script, our column looper, or our column object pool. Okay, let's pause for a second and let me check the chat, and then we will continue. The next thing that we're going to want is an object pool, which is going to spawn our set of columns that we're going to use and then reposition them once we need new ones. So instead of spawning, hundreds of columns that we then move through from left to right, we're just going to spawn 5 columns and reposition and recycle them once they become invisible, very similar to what we're doing with our background. And for those wondering why we do this, it's because it is much more performant. So the pattern, the design pattern that we're using is called object pooling. And so to quote Wikipedia, the object pool pattern is a software creational design pattern that uses a set of initialized objects kept ready to use, a pool, rather than allocating and destroying them on demand. A client of the pool will request an object from the pool and perform operations on the returned object. When the client has finished, it returns the object to the pool rather than destroying it. This can be done manually or automatically. Object pools are primarily used for performance. In some circumstances, object pools significantly improve performance. This is definitely true for game development. Object pools complicate object lifetime as objects obtained from and returned to a pool are not actually created or destroyed at this time, and this thus require care in implementation. So what they're saying there is because the object's not just going to be spawned new, you may need to have some kind of reset function if it's a complicated object to make sure that everything is reset when it goes back to the object pool. And that'll be dependent on your game and your objects. But basically what we're doing is we're creating a pool of objects and then just reusing those same objects. So we're basically calling instantiate once. So basically the idea is that we are going to spawn a set of objects and just reuse those. So we're going to call instantiate once at the beginning of the game, and then we're never going to instantiate or destroy anything while the game is running. And what that's going to prevent are frame rate drops due to garbage collection because we're cleaning up memory from instantiating and destroying objects. So for more on that, please check out the article about it at unity3d.com/learn. And so I'm going to show you guys a nice, simple object pooling implementation here. So the first thing that we're going to do is select the game controller, choose add component, and this is going to be called column pool. And we're going to create an add and put it in our scripts folder, and then double click it to open it for editing. Now, the first thing that we're going to need is going to be an array of columns. So this is going to be a private game object array called columns. And we're also going to need a size for that array, and that's going to be public. So let's put it up here. This is going to be a public int called column pool size, and that's going to be equal to or initialized at 5. Now, in start, we want to set up the array. So the first thing that we're going to do is we're going to say columns equals a new game object array, and the size of that is going to be column pool size. So we're making a new empty array of game objects with 5 empty slots. The next thing that we're going to do is fill that with new spawned column prefab objects. So the first thing that we're going to do is we're going to make a for loop, and you can just type for and then double tap tab, and then we just need to replace max here with column pool size. So we're going to loop through the array. We can leave I, the default iterator, and we are going to need to instantiate at the beginning of our game our column. So we're going to need a public game object variable called column prefab. That's the thing that we're going to instantiate. And in the for loop, and we're also going to need a private vector2, which is going to be our object pool position. And we're going to set that here. That's going to be equal to a new vector2, which is going to be at -15, -25. And that is just a position that is off screen. So it's going to be a pile of stuff off to the side where we're going to initially spawn them. Once we start using them, they're just going to be positioned in different places. So that's just for the first, before we start using them. Now, once we've got our position and our prefab that we want to spawn, we're actually going to instantiate them. So we're going to go through the loop, and for each slot in our index, so columns I is going to be equal to GameObject instantiate. The thing we want to instantiate is the column prefab. The position we want to instantiate it at is object pool position, and we're going to use quaternion.identity to use the rotation of the prefab. So we're instantiating an object, casting it to a game object, and storing it in our array. And we're doing that for each slot in the array, right? So we're going to do that 5 times. Now, that's set up our pool, right? That's going to happen in start. It's only going to happen once. Now, in update, we're going to set up a little timer to check if it's time to reposition a new column in front of the player. So we're going to need a private float called time since last spawned. So that's going to store how much time has passed since we last put a column in front of the player. And then we're also going to need a public float, which is going to be called spawn rate, right? So that's going to be initialized to 4. That's how often are we going to position a new column in front of the player from the pool. So in update, we're going to count the time that's elapsed. So we're going to say time since last spawned plus equals time dot delta time, which is the time that it took to render the last frame. So we're going to add that to our timer. So we're counting up, right? And then we are going to check if it's time to spawn a new column or to position a new column, right? So we're going to say if gameControl.instance.gameOver equals false, right? Because we don't want to position new columns if the game is over. And time since last spawned is less than or equal to spawn rate. So if the time since we last spawned is less than 4, I'm sorry, is greater than 4, is greater than. So if it's been more than 4 seconds since we last spawned, then, and the game is not over, then we're going to do the following. So what we're going to do is we're going to generate a random position along the Y and position our column there. So we're going to have random offsets vertically to position the columns. So we're going to set a range for that. This is going to be a public float called column min, and we'll start that at -1. We may need to play with these values a little bit in the inspector, but they're public, so we can do that. And then we're going to have a public float column max, which is going to be equal to 3.5. And we're going to use these to generate a new position. So first of all, if that evaluates to true, we're going to reset the time since last spawn. That's going to equal 0. And then we're going to declare a float called spawn y position, and that's going to be equal to random.range between column min and column max, right? So we're generating a random number, in this case between -1 and 3.5, and storing it in spawn y position. The x position is going to be fixed, so we can make a private variable for that. That's going to be a private float called spawn x position, and that's just going to be equal to 10, which is just a position 10 units to the right off in front of the camera. So they're going to be positioned off screen, and then they're going to scroll towards the player, come into view. So we also are going to want to keep track of what column from the array we're repositioning, right? So we're going to have a private int called current column, and that is going to start off equal to 0. So we're going to position the column 0, then we're going to position column 1, and eventually we're going to loop back to column 0 and just keep repositioning those same 5 columns. So now that we've got our random Y position and our fixed X position, we are going to we're going to position our column. So we're going to say columns, the array, the current column from that array. So we're going to start with column 0. The transform position of that column is going to be equal to a new vector 2, which is going to be made up of spawn X position and spawn Y position. So we're generating a fixed X coordinate, a random Y coordinate, and setting it to the current column that we're working with. The last thing that we need to do is just check. Oh, before we do that, we need to add 1 to current column. So we're just going to say, okay, we've positioned that 1. Let's move from column 0 to column 1. And then, since we've done that, we want to check if current column is greater than or equal to the total size of our pool of columns, right? So basically, if it gets to be more than 5, then we just want to reset current column to equal 0. So we're looping through our pool. We're going to position 0, 1, 2, 3, 4, 5. Once we get 5, we're going to go back and grab 0 and position it again and just keep repeating, right? So this is a little abstract, but I'll show you how it works in practice. So let's save that. And this is our last script. So we're reaching the end here. So let's save that, hit OK there. And we're going to return to Unity and make sure that in our game controller, we've added our column prefab to the column pool. Just going to drag columns in there. We may need to adjust these numbers. Let's double check. And then we're going to, let me zoom way out so we can see everything happening in the scene view. So we're going to hit play. So you can see there's our off-screen position where all the columns are spawned, and now it's positioned the first one. Actually, the position looks pretty good so far. No, see, that one's a little wacky. Let's see if I can get over there. Nope. Okay, so let's dial it in a little bit. Let's go for the minimum. Let's make it maybe -2, and the max will be maybe 2. Let's try that. That looks better. Yeah. Now I just have to play Flappy Bird. And as you can see, our columns are being spawned and hopefully, died. This always takes me forever to demo. Our columns are being spawned. Let's see if I can get through 5 so that we can see one of them reposition. But basically, once we get through 5 columns, the first one is going to be off screen. Here, you know what I'm going to do? I'm going to cheat. Let's turn off the collider on the bird. Ha ha! Because I'm terrible at this. So, as we go, we've got 1. I'll pretend that I'm really doing it. Oh, look at me, I'm so good. Now we've got 3 spawned. Our background is repositioning. We've got 4, and if you watch that first one, you should see it reposition once we run out of, there we go. So we can see it repositioning there. Oh, and of course I'm not getting any points, right? Because I'm a cheater and my collider is turned off, but that's fine. So we can see there's all our columns. They're being repositioned forward. And the advantage of this is that we really can keep doing this forever. So the issue with if we were actually moving to the right is that eventually we would start getting into really big numbers that we would run out of floating point precision and we would start getting glitches and errors. And this is true in both 2D and 3D games. In Flappy Bird, it's really not that much of a problem, but setting things up this way is just generally much more performant, especially if you're trying to go for mobile, and also will avoid running into those kind of accuracy issues. The other approach to it is what's called a floating origin, which is more common with 3D games like 3D Endless Runners, for example. We have a game that we're releasing to the asset store soon called Trash Dash, which is a 3D Endless Runner. And in that, we use what's called a floating origin. And instead of continuously scrolling things, just after a certain point, we take the whole world, all of the 3D geometry, and we just reposition everything back to zero. So it's not happening continuously. It happens in like single jumps once in a while. And that basically prevents us from ever moving too far from the origin and running into floating point precision issues. So just to kind of recap the ideas of what we learned here, the goals from this session, we looked at learning how to create performant, infinite, or endless style games by moving the world instead of the player. We learned to optimize our game using object pooling to create the illusion of many objects using only a few. And we also looked at creating cartoon-style, non-realistic 2D physics using Unity's built-in physics system. So, hopefully that was helpful for you guys. Thank you for sticking with me for an extra long session today. And I appreciate you because you're great. It's always great to see all the regulars. Warm welcome to all the new folks joining us on the stream. This will be archived both on Twitch and on YouTube in a few days, and all of the scripts and assets will be made available via the Unity website, so check back there. And yeah, thanks again for watching. I'm going to take a few questions from the chat, although not too many because I actually have to run out. But yeah, thanks again, and see you next time. Yes, the videos for this will all be uploaded to YouTube soon. Yeah, I would say if you want to learn, like you can learn a lot of all like the design patterns that I pointed out, like the singleton pattern and the object pool pattern. Those are just patterns that are true in software development, not just in games and in any programming language. So that kind of like more computer science theory, you can learn from a book, great, because it doesn't change. Unity or any specific piece of software is usually changing really fast. So by the time you get a book, it's probably out of date. So that's kind of the limitation of that. That's why like using the Unity website is probably the resource I recommend, you know, not just because that's my project that I work on, but that's my perspective on that. Yes, we will be continuing on Twitch. We will be doing live training every 2 weeks. There's a couple more sessions coming up in the next few days, actually, with Mike Geig. You can find the whole schedule at, I'll post a link in the chat. It is here. Somebody's asking about version control software. We use Mercurial with Tortoise HG in the office. I've also used Tower with GitHub on a Mac at home. I don't think it really matters that much. Unity has a collab version control style platform coming soon, but it's not out yet. That'll be integrated with the editor. Iron Oxygen asks, would you recommend the singleton structure for most projects? Personally, I'm finding it great. Is there any downsides? You know, I personally like it as an approach, and I can't come up with the downsides off the top of my head. If you look, you know, do some research, Google singleton pattern game design, and you'll find some people who will be like, no, it's the worst thing since ever, and burn it with fire. You should always do my favorite pattern. There are people who just like and prefer a different pattern, and every design pattern has strengths and weaknesses. I think, especially for a small, simple game like this, it's great. And I think it's an interesting pattern to have in your toolbox. I would read up on someone who disagrees with it to see what they see as the limitations. So you can decide, how you want to address those. But I think it's a nice pattern. The programming in the Unity, so Iron Black Man asks, did the programming in the Unity editor change since 5.3? Not significantly. It's really, there's a couple small changes to the API and mainly new features and stuff. Generally speaking, we try not to change old features. We mainly add new stuff, but there may be small changes. You'll have to take a look at the release notes to see if there's anything that really affects you. Evantro, I don't actually have a great answer for you about that, about positioning scroll views programmatically. I would have to get back to you on that. I don't have an answer off the top of my head. SHMOCM asks, does Unity have or support or a preferred library for dependency injection and unit testing, integration testing? The short answer is no. And I've never actually worked a lot with dependency injection. The only kind of anecdotal advice I can give about this is a friend of mine, actually Kerry, who's another programmer at Unity, or a programmer on the R&D content team, was saying, generally speaking, people who come from a dependency injection background tend to get a little sort of messed up with Unity because it's not a pattern that kind of Unity supports very well or that it works with very well. So that generally speaking, you kind of want to learn the Unity way of doing things, and that dependency injection can kind of conflict with that. Not knowing more than that, I can't really give great advice, but I would just say, look out and be careful and do a little further research. Okay. The VOD for this on Twitch should come up quite quickly. It's kind of a longer session, so it might take a minute or two, but I think once I cut the stream, it should pop up pretty quickly and be there, any minute. Yeah. Okay, guys, I'm going to cut it there. Thank you so much for sticking around for this marathon session. I really appreciate it, and it's great to see you all. And I will be back in 2 weeks with another live session. Please keep an eye on the schedule. I think we might move to Wednesdays at this time. That's something we've been talking about. And so I will update the schedule once I confirm that that's something that we're going to do. But we may move from Monday to Wednesday at the same time, keeping our every 2 weeks schedule. And also check out starting on Wednesday, Mike Geig will be doing a 3-day marathon special on creating a networked multiplayer FPS, which he calls his Merry Fragmas. And this will be Merry Fragmas 3.0. He's done it for 2 years. It's a lot of fun. So I recommend you guys check that out. And yeah, thanks again for watching, and I will see you in 2 weeks. Bye.